So we're going to start right on number 9 from your day 7. All right. So on the back of day 7, right at number 9. Okay, so you want to find the exact value of the sine of a plus b given cosine is in quadrant 3 and sine of b is in quadrant 2. So first and foremost, this is a formula right from your formula sheet. So we're going to copy that in a second. And these are the type where you want to draw your pictures. So we are given that angle A is in quadrant 3. So I'm going to draw a little sketch for A here. Place that down here. Again, this is my picture for A. And then I have cosine is -5/13. So cosine is your adjacent over your hypotenuse. Now, how can you solve for the last leg of that triangle? Pythagorean theorem, right? Do any of you guys actually just know it? This is called a Pythagorean triple. It's just a commonly occurring right triangle. So this is equal to actually just -12. Yep, so again, Pythagorean theorem would work for that as well. Now you're going to go and set up your second picture. So next picture, I have sine of B, and angle B is in quadrant 2. So I'm going to go picture for B. And then in this case, you're going to be in quadrant 2 instead. So quadrant 2. And this time you have 15/17. So you're going to go opposite. And then you're going to go hypotenuse. And then to solve for your missing side, you would do Pythagorean theorem. And that's going to be an 8. Okay. So next you're going to look at your formula sheet. So your formula sheet, if you look, this is on the right-hand side. It is 1, 2, 3, 4 boxes down. You're going to pull the formula that says sine of x plus y. Or again, you can change it to a and b. It makes no difference. So I'm going to do the sine of a plus b. And this is equal to, so I have the sine of a and the cosine of b. And then this is plus, this problem's quick, so you can use some of that space. And then I'm going to go the cosine of a and the sine of b. And that's it. You just have to plug them in. So you're going to have 4 fractions here. So the sine of a, I go over to picture A, and you're going to place the sine in here. So sine is opposite over hypotenuse. I'm going to go -12/13. Next, you're going to go cosine of b, adjacent over hypotenuse. So that would be -8/17. Next, you're going to go plus cosine of a. So cosine of a is your adjacent over your hypotenuse. And then you're going to go sine of b. And sine of b is your opposite over your hypotenuse. So 15/17. That's it. Type them in, answer. So everything gets typed right in. Again, just like that. That's the only work that you have to show is your pictures and your formula. You have -12/13 times -8/17 plus -5/13 and 15/17. Math, enter, enter. Answer is 21/221. Okay, how do we feel on that type, guys? Okay? Okay, again, it's been a while since you've done those. So number 12, I'm going to prove. So similar to what you saw yesterday. So what do you suppose I should do with the sine? Because it's in both of these expressions. What did we do with this yesterday? Guys, remember? You're going to GCF it out. So I take out a sine squared x. And I'm left with a 1 plus tan squared x. Anytime you have a squared in one of your trig functions, these are Pythagorean identities, and these are located on your formula sheet. This is the third box down. So this is going to get replaced with secant squared x. So I have sine squared x, and then this becomes secant squared x. And then what can we rewrite secant as? Exactly, 1 over cos. So I keep going, and you're going to simplify. So secant is equivalent to 1 over cos squared x. So then I'm going to multiply these, and I get sine squared x divided by cos squared x. And you already know what the answer is supposed to be. So is sine over cos equal to tangent? Yep, absolutely. So this is equal to tangent squared x. So I'm just going to go like check. Good to go. All right. How's that type? Pretty good? Okay. So number 10, find the exact value of sine of 2 times c, given that sine of c is 12 over 13, and angle C is in quadrant 2. So you're going to sketch a picture with a triangle in quadrant 2. And then you're going to go right over to your formula sheet. So quadrant 2. And this is angle C. So I have opposite and hypotenuse. And again, if you did Pythagorean theorem, this is going to be a 5. And it's negative because you are left of 0. Now you're going to look at your formula sheet, and you're going to find what's called a double angle identity. So sine of 2c is the box 1 up from the bottom. So you're going to go sine 2 theta equals 2 sine theta cos theta. I'm just going to use c's instead. So you have sine of 2c equal to 2 sine c cos c. And then cos c. And it's going to look just like your problem above where you have all the little fractions. So I'm going to go 2. And then sine of c was given to 12 over 13. And cosine is adjacent over hypotenuse. All right, that can go right in the calculator, or you can kind of do it in your head. 60 times 2 is 120, and then over 169. So negative 120 over 169. All right, how do we feel on number 10? Are those okay? Okay, and again, I wanted to give you some time to process that. It was going to be too much to just throw it all at you next week. So number 13, here's where these get a little bit lengthier. You are given 6 sine squared theta, 5 sine theta plus 1 equal to 0, and you want to solve for all answers that work. This is a trig quadratic equation. That means there are 4 answers possible for this. So what you're going to look at here is, because this is quadratic, you can either try to do AC factoring with it, or you could go right to quadratic formula. I'm going to give you a quadratic formula with this one just because it works every single time. So for quadratic formula, you go A, B, and C, and you put sign back in afterwards. So I go x is equal to negative b plus and minus square root of b squared minus 4ac all over 2a. And again, you can expect 4 answers to be possible at maximum for this. So you're going to place in your 5. So I have x is equal to, I'm going to go negative 5 plus and minus. And we've got the square root, so b squared. So 5 squared minus 4 times 6 times 1. And then this is all over 2 times a, which is 12. So you're going to keep going with this. So I have x is equal to, so again, I'm ignoring the trig function for a minute. And then plus and minus 25 minus 24 is 1. And then over 12. So this would have factored, but again, sometimes it's tough to factor those trig functions. So this is something you're a little bit more comfortable with. Square root of 1 is just 1. And then you're going to branch this off and get upwards of 4 answers. Okay, so first case scenario. We can have -5 plus 1, which is -4, divided by 12. So that would give me -1/3. And then the other one, so I would go -5 minus 1 over the 12, so that would be -1/2. Okay, now you have to put your sign back in. So I'm going to come up here and do sine of x equals -1/3. And then my other side here, kind of split this like this, I guess. I'm going to go sine of x equals -1/2. All right, then this becomes calculator work. Which quadrants is sine negative in? So ASTC. Yep, very good, 3 and 4. So then what I'm going to do in the calculator is second sine of 1/3 to get my reference angle. Because again, we already just took care of that negative. So you're going to go second sine of 1/3, and that is equal to like 19.5. I'll round that to 19.5. And then you're going to find your two answers. So 180 plus 19.5, and then 360 minus 19.5. So the first two answers are 199.5 and 340.5. Next, you go and get the other two, again, if they're possible. So then I'm going to say, again, where is sine negative? Same place. So here and here. But instead, you're going to type in the calculator second sine of 1/2, which hopefully we know. What angle is that? Sine of 1/2 is sine of 30. Good. Yeah, again, we got to know those. That's good review for you. So 30 degrees. So 180 plus the 30 would be 210. And then 360 minus the 30 would be 330. Okay, how's that type? Again, that's the type I think you're probably going to need some practice on. But you've got some of those in your homework as well to, get comfortable with again. So number 11, find the exact value of cosine of b divided by 2. So this is another formula off your sheet, given that your angle is in quadrant 3. So you're going to draw this. We are in quadrant 3. Adjacent over hypotenuse. And does anyone remember this other side? Special triangle? Yes, it is 4. And again, if you forget, you just do Pythagorean theorem quick. So that missing side is a -4 because you went down. So currently we are in quadrant 3, which means that our angle is between 180 and 270. And you're looking to find half. So half puts me to 90 and then 135. And the reason you're looking at that is because that bumps cosine into quadrant 2. And in quadrant 2, is cosine positive or negative? Negative. So that's the formula that you use. Cosine is negative there. So your formula has a plus and minus, but we only use the minus for this one. So you're going to go cosine of b over 2 is equal to the negative. Again, you don't use both. It's either going to be one or the other. So you have 1 plus cos of x. So cos of b in our case, and divided by 2. Divided by 2. All right, so this is equal to negative square root of 1 plus -3/5 over 2. All underneath the square root, but don't do that part yet. So in your calculator, you might want to do 1 plus -3/5 and divided by 2. And I got the square root of the 1/5. Now you're going to keep going with this. So this is equal to negative square root of 1 is 1. Square root of 5 stays like this. And then I'm going to rationalize this. So times radical 5 over radical 5. And that becomes your final answer. So answer is negative 1 radical 5 over 5. Again, it has to be an exact value. So no decimals. How's that type? Okay. Again, when you've got questions, make sure you're asking. Now you get to 14, and does 14 look different? What do you notice about your trig functions here? How many do you have? 2. You can't have 2. What you have to do is a substitution. You have to get rid of one of these. So you're going to look at your formula sheet and determine which one do you know something about. So sine squared theta is a Pythagorean identity, and you can replace that. Your other one, 2 times cos theta, there's nothing else you could do with that because that's not a double angle identity. So where you see this, you're going to replace it with 1 minus cos squared theta. And then that's equal on the other side to 1 plus 2 cos theta. Now you're good. So you've got everything in terms of cosine now. All right, what happens to the 1s? Yeah, those cancel. That's nice. And this is another quadratic, so you want it equal to 0. I'm going to move this over to make it positive. So if 0 is equal to, I'm going to go cos squared theta, and then plus, and then 2 cos theta. And this is up to you. If you want to do the quadratic formula again, you certainly can. But isn't this one faster to just GCF? Yeah, so take out your GCF. So you have a cos theta. And then you are left with cos theta plus 2. And then plus, and then 2. And again, when you solve the trig quadratic equations, you can have a maximum of 4 possible answers. So then I'm going to t-chart this. So I get cos theta equals 0. Then on my other side, I get cos theta plus 2 equals 0. So this one's going to be cos theta equals negative 2. And then I guess we'll go back to the left side. So cos theta equal to 0, this is a unit circle question instead. So you would be looking for what x values give you that answer. Or if you want to just pick up your calculator and type them in. So type in cos of 90, cos of 180, cos of 270, cos of 360. What do we get? So, yep, 90, and there's one more. Should be 270 as well. Because on your unit circle, cosine corresponds to the x value. And those are your 2 locations where x is 0. So first 2 answers are 90 and 270. All right, so over to the other side. So I'm going to plot this again. And cosine is negative, ASTC, in quadrants 2 and 3. So you're going to see something different here. When you go to type this in the calculator, what does it tell you when you do second cos of 2? Yes. So this is not possible. By definition, cosine is an adjacent over a hypotenuse. Can it ever exceed 1? No, because isn't your hypotenuse always your biggest? So this is not possible. So this question only has just those 2 answers. Okay, so it doesn't have to necessarily have 4. All right, can you guys find some space for one more question, please? I want to give you another trig quadratic equation. Is that okay? Again, I foresee those to be a bit problematic. I'm going to give you one more of those. I'll call it, I guess, question 15. I don't know where you have some space somewhere. All right, so one more of that type. All right, I want to go 5 sine squared x. So 5 sine squared x. And then minus 2 times the sine of x equal to, and we're going to go cos squared x. All right, so continuing here, when you look at these, so I can only have one trig function in my equation here. So what can we substitute? I think you kind of just did one like this. Yep. So again, that's a Pythagorean identity. You're going to place that in. So I have 5 sine squared x. And then minus the 2 sine of x. And then equal to 1 minus sine squared x. Again, it's another quadratic. So what do quadratics need to be equal to? 0. Good. So I'm going to add the sine squared over, subtract the 1 over. So we're going to move this over. Again, put it with this one. You can combine those. So I have 6 sine squared x minus 2 sine of x minus 1 equals 0. And then again, I want you to practice the quadratic formula because that works every single time. So right now, ignore your sine function. So you're going to use a equals 6, b equals -2, c equals -1. So x is equal to negative b plus and minus the square root of b squared. So I'm going to go -2 squared minus 4 times a times c, and then all divided by 2 times a. So 12 again. So then you're going to keep going. So I get x equal to, we've got 2 plus or minus the square root. So you have 4 plus 24. So we've got 28 over 12. I'll break this root down just so when you go to do your next part, it's a little bit simpler. So 28 is divisible by 4 and 7, which means this is 2 plus or minus 2 radical 7 over 12. And now you can reduce those values as well, just so, again, it makes your next part a little bit easier. So divide everything by 2. You've got 1 plus or minus 1 radical 7 over 6. Okay. Guys, any questions on that part so far? So again, just treat it normal. Now you're going to put your sign back in, and then you're going to draw your 2 scenarios here. So now I'm going to go sine of x. So you place it back in now. Equals. So I have 1 plus the square root of 7 over 6. So here's my first case. And then I have sine of x equal to 1 minus the square root of 7 over 6. All right, so obviously my first side over here, this is going to be positive. So where is sine positive? Quadrants 1 and 2, good. So if you want, type in that fraction first. So go ahead and do 1 plus the square root of 7 over 6 and just hit enter. And you get a decimal. It should be like 0.6076. Okay, so now you're going to go second sign of that decimal. So second sign of, that just worked out to 0.607625, etc. So second sign of that, again, making sure your calculator's still in degrees. I think you guys are good. We'll go nearest 10th again. So how about 37.4? So actually that's your first answer because that's quadrant 1. And then quadrant 2, I'm going to go 180 minus that. So next answer is 142.6. How do we feel on those two, okay? All right, now over to the other side here. So I'm gonna do, I think this one comes back negative, doesn't it, even when you type it? Yes. So sine is negative now in quadrants 3 and quadrant 4. So I'm gonna type in this decimal again, ignore your negative because we just used it for quadrant placement. Second sine of, I'll write it in case you'd like it. So this is second sine of 0.27429. Just going up and grabbing it 1 second. And I got 15.9. So that is your reference angle, and now you need to work with that. So 180 plus that, and 360 minus that. So last two answers, 195.9 degrees and 344.1 degrees. All right, so this one did have 4 answers. Everything that just gets boxed right here. Okay, are there questions specific to those topics, or are those okay? Again, when you guys are doing the homework in the packet, the day 7, that's all this trig. If something bothers you in the next week, just circle it. When you return next Thursday, we can kind of talk about those. Good there? Okay, so the remaining time is yours for your quiz. So everything away except for formula sheets, please. It's your last quiz of the year. So quick and easy. You've got 25 minutes if you need it. And remember, your homework are just those worksheets that are stapled together. There is nothing online this week.